Hello everyone, this is your teacher Adam Asif Naviwala and I'm back again with a revision video series on O-level maths. Today's video is going to be based on O-level maths vectors. We are going to cover some basic concepts and then you can reinforce those concepts using a past paper question. So let's begin. Now we are going to have a discussion on parallel and opposite vectors. So what you see in front of you is a Cartesian plane y and x, and there are some vectors drawn for you. This is vector A, there are two vector B's, and there are three vector C's. Now we are going to talk about the direction in a couple of some time. If I just write vector A in terms of its column vector, okay, you would agree with me that the column vector of A comes out to be 1, 2, 3, 4. So 4 units over here, 4 and 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it comes out to be 6 and 12. Vector B on the other hand is 1, 2, 3, 1, 2, 3, 4, 5, 6. So vector B comes out to be 3 and 6. Vector C, just one vector C comes out to be, if that's their starting point, -1, -2, -2 and -4, as you can appreciate it from the diagram. So that means that I would be needing, if B is 3, 6 and A is 6, 12, in order to have this much length of vector, I'll be needing two vector B's, right? So I need to have, this is one vector, I need to have another vector B so that I can say that the length, I can get the same line segment. So this means vector A is going to be equal to twice of B. Vector A is equal to twice of vector B. If I am going to multiply vector B by 2, I am going to get vector A. Now let's discuss vector C now. Vector C, I'll be needing three vector C's to make it equal to vector A की length. However, vector C's are in the opposite direction, and so vector A and vector C are in opposite direction. So yes, I'll be needing three vector C's to make it comparable to vector A, but since these are vectors, directions are important. I'm going to say that vector A is equal to -3 times of vector C. That shows that it's in the opposite direction. So if you multiply vector C by -3, then only you are going to get vector A, because -2 times -3 is going to give you +6, and 4 times -3 is going to give you 12. That was -4. Okay, so -4 times -3 is going to give you +12. Alright, so vector A is not equal to vector B. However, vector A is twice of vector B, and vector A is -3 times of vector C. These values of 2 and -3 are basically going to be called the scalar multiples, scalar values, scalar multiples. Also, you can see that these vectors are parallel. Vector A, the line for vector A and the line for vector B and the line for vector C are parallel to each other. So when the vectors are parallel, one of the criteria for that is going to be they should be scalar multiple of each other. Okay, so we are going to start our discussion from here. So if we know that A and B are two non-zero and parallel vectors, and A vector is equal to k times vector B, where k is any scalar number. So if k is greater than 0, meaning let's say k की value is 2, 3, 4, then you will have a vector that is going to be enlarged. So this was just B vector. If k value is greater than 0 and let's say even greater than 1, let's say 2. So 2b is going to be double the size of vector B. If k value was less than 0, however, as in the case over here -3, that was indicating the opposite vector. Okay, so also if A is k times B, vector A is k times B, then vector A and B are parallel and are in the same direction if k is greater than 0, but in the opposite direction if k is less than 0, as we have discussed over here. And the magnitude of the vector A is also going to be the same scalar multiple times the magnitude of vector B. So if I know that vector A was twice the vector B, then the magnitude of vector A is also going to be twice of vector B. Okay, the length of vector A is going to be double of vector B then, if vector A was twice of vector B. So if k value was 2, then the vector length is also going to be 2 times. Then there is a concept of collinearity of vectors, which simply means that the 3 points A, B and C are going to lie on the same line, and the vectors A, B, BC and AC are going to be collinear. So if you know that 3 points, if you know that A, B and C are collinear, that means A, B and C all lie on the same line. For example, A, B and C. The 3 points lie on the same line. If the 3 points are collinear, then they must lie on the same line. And if we talk about in terms of vectors, vector AB, vector BC and vector AC are going to be parallel vectors. And if the vectors are parallel, I can represent vector AB in terms of vector BC by some scalar value. I can represent vector AB in terms of vector AC by some any other scalar value. यानी कि AB could be 1/4 of AC, AB could be half of BC. I'm just making these numbers up, but you get the idea, right? AC, vector AC is, let's say, 3/2 times vector BC. So K, P and Q over here are just these scalar multiples, non-zero scalar numbers. Okay, and if conversely if AB vector is K times vector BC, then you know the following things, that AB is parallel, if AB is parallel to BC and if B is the common point over here, then you can conclude that A, B and C are going to be collinear points. So there are 3 conditions for collinearity. If one vector is represented as a scalar multiple of the other vector, the 2 vectors must be parallel and there should be a common point. So B is a common point, then you can conclude that the 3 points A, B, C are going to be collinear. So let's look at a question at hand. If you are given that OP vector is 2A minus 5B, OQ vector is 5A minus B, OR is 11A plus 7B, you need to show that P, Q and R are collinear, and then you need to state the ratio of PQ is to QR. So this is how you are going to solve. To show the collinearity, you need to prove that PQ and QR are equal vectors with a scalar. Okay, and to find PQ, recall that the combination of position vectors must be OP and PQ. So for first thing first, you're going to find PQ vector, which is going to be, so we have been given OP, OQ, right? PQ is going to be PO using the vector array PO plus OQ. So I have been given OP in the question. PO is just going to be negative of 2A minus 5B plus OQ, that is 5A minus B. So if you simplify this, you get 5A minus 2A, that is going to give you 3A, plus 5B minus B, that is going to give you plus 4B. Now you have PQ vector, okay? Then what we can do is we can find QR, and QR vector is going to be QO plus OR. QO is going to be negative of OQ, that is 5A minus B, and OR is given to you as 11A plus 7B. So minus 5A plus B plus 11A plus 7B, 6A plus 8B. Okay, so PQ is 3A plus 4B and QR is 6A plus 8B. We were asked to show PQ and R as collinear. So the first condition for being collinear was that they should be scalar multiple of each other. So if I take 2 common from here, I am going to get 3A plus 4B. So you see, PQ is 3A plus 4B and QR is 2 times 3A plus 4B. So I can conclude, I can say that PQR is twice of PQ, okay, and PQ is going to be 1 over 2 of QR. If QR is twice of PQ, I can rearrange and write the equation as PQ is going to be half of QR. That simply means that if this is P, this is Q, and this is R, if PQ is just half of QR, okay, so if this is 2 units, QR is 2 units, PQ is just going to be 1 unit in length, okay, and QR is twice as much as PQ. So since PQ vector is half of QR vector and PQ is parallel to QR, and you can see that Q is a common point, you can say that P, Q and R are collinear. And the next thing that you have been asked is the ratio of PQ is to QR. So if PQ is 1, then QR is 2, okay, that's the ratio. Because PQ was half of QR, then for the ratio you can find it like this, that PQ is going to be 1 unit, QR is going to be 2 units. Now finally, the concept of position vector is also very simple. Position vectors, any point in a Cartesian plane, if linked with the origin, is going to give you a position vector. So if this point P has a coordinate of 2, 5 and it's marked over here, then if you join this point with the origin and join them with a vector in this direction originating from O, that is going to be your position vector OP. So OP is just the OP in terms of its column vector is just going to be the coordinates. So OP means that you need to move 2 units in the x and 5 units in the y direction. So OP vector is just going to be 2, 5. And similarly OQ vector, q is a point with having a coordinates of 6 comma 3. So OQ vector is 6, moving 6 units here and 3 units here. So that's 6 3. Okay, so OP in terms of letter could be represented by as vector P. OQ could be represented by vector Q. Alright, so if I want to find PQ vector means going from P to Q. So you can go from P to O and then O to Q. So I can go from P to O, okay, plus O to Q. This is O. Okay, so if OP was 2 5, then PO is just the negative of OP and the rest remains same. Negative of OP, which is 2 5, plus OQ, which is 6 3. So minus 2 minus 5 plus 6 3. So if you add the x components together, you get 4, and if you add the y components, you get negative 2. So 4 and minus 2. So 4 units in the x direction and negative 2 units in the y direction. That is our resultant vector PQ. So PQ can be represented in terms of its position vector, okay, and this was coming out as minus OP plus OQ. So I can rewrite this vector PQ in terms of its position vector as OQ minus OP. I can write the second vector first and then the negative vector afterward. It's not going to make any difference, but this makes the life simple. So if I ask you what is PQ vector going to be in terms of its position vector, you are going to say OQ minus OP. If there was any another vector, let's say AB, and if I would have asked you what is that going to be in terms of its position vector, you are going to say OB minus OA. It's always the position vector of the second letter minus the position vector of the first letter. Okay, EF in terms of its position vector can be expressed as OF minus OE vector. Okay, now coming back to this example again, if OP vector can be represented as small p and OQ can be represented as small q, and I have been asked to express PQ in terms of small p and q, then that's going to be this. See, you need to move from P to Q, so you will go in towards P, from P to O. So if OP was given to be as P, OP is given to me as P, and OQ is given to me as Q, then I am traveling opposite of P direction. So I am going to write negative P and I am going along with Q direction, so plus Q. So in terms of P and Q, I can either write PQ as minus P plus Q or PQ as Q minus P.